Hello. We are doing a division proof today by induction, taken from Discrete Mathematics and its Applications by Kenneth Rosen. 7th edition is what I'm using. So my question is from chapter 5.1, question 31. Yours may vary if you have a different edition of Rosen. This question is asking us to prove that 2 divides n squared plus n when n is a positive integer. So for this proof, we're going to have to use the notion of divides. Now, because you're doing a proof that uses the notion of division, I'm assuming that you understand somewhat the notion of division of integers. So we say that an integer divides another integer. We're going to use this notation. This means divides, vertical line. It means it divides it equally. If I say x divides y, this means also that I can write y as an integer multiple of x. So where k is just some integer. So we should see that here because 4 is equal to 2 times some integer. It happens to be that k is 2. So that's what the divides mean in this sense. 2 divides n squared plus n. We are saying 2 divides n squared plus n when n is a positive integer. So n is greater than or equal to 1. So this proof will be by induction on n. And with any induction proofs, we're going to start with a base case. Since we're assuming that n is positive integers, we are looking at the P1 case, or n equals 1. So we want to see does 2 divide n squared plus n when n is 2. Well, n squared plus n is 1 squared plus 1 is 1 plus 1 is 2. And 2 divides 2, obviously, because we write 2 as an integer multiple of 2. 2 times 1 is 2. So the base case holds. Excellent. So now we're going to do the inductive step. Or the PK case, which we are going to assume is true. So we are assuming here that 2 divides and we are replacing it k squared plus k. So we're assuming this is true. This is our induction hypothesis. I like to write IH. So we're assuming that k squared plus k is divisible by 2, which will mean that we can write it as an integer multiple of 2. I just want to write this a little better. Oops. What happened there? All that, and that's not that much different. Okay. So what do we want to show then? We want to show that the pk plus 1 case holds. P here is the statement. So when we say pk, I'm writing it 2 different ways. I'm saying pk, and then I'm saying this. I'm saying pk plus 1, but then I'm going to write what I mean by that. So 2 divides, and I'm replacing k squared plus k. Each k I'm going to replace with k plus 1. So this becomes k plus 1 squared plus k plus 1. So this is a question. This is not an assumption. This is what we want to show. We want to show that 2 divides k plus 1 squared plus k plus 1. All right, so let's look at k plus 1 squared plus k plus 1. Of course, k plus 1 squared means I'm multiplying the binomial k plus 1 to itself and then adding k plus 1. So let's multiply this. We're going to do this by FOIL. First, outer, inner, last. If you're unfamiliar or need a refresher, I did a lecture 5 about polys, multiplying, adding, subtracting, and foiling. If you need a review, look for lecture 5 in the college algebra section. Now, what I'm going to do here is FOIL, so that I'm going to get k squared plus 2k plus 1 plus k plus 1. Okay, so at this point, we usually group like terms and we'll factor and then say, okay, we're done. But let's be a little more strategic. You should resist the urge at this point to combine like terms. The reason is because we want to use the induction hypothesis. That's this here, right? That 2 divides k squared plus k. So what I'm going to do first is I'm going to combine k squared plus k. And I can group them this way because addition is commutative over the integers, so there's no problem with that. I'm going to add it to what remains. What remains here is 2k plus 2. Okay, now by the induction hypothesis, I don't know why 6, but 2 divides k squared plus k. Now, I said above that we can write anything that divides something is an integer multiple of its dividend. So that means that k squared plus k is equal to 2, let's say m, for some integer m. So I can replace this in this equation with 2m, because that's the assumption, that's the induction hypothesis. Now I could factor a 2 out of this binomial. Then we get k plus 1. Now notice that each term has a 2, so I'm going to factor a 2 out, and I'm left with m plus k plus 1. Now, m plus k plus 1 is an integer. Two times an integer means that it's divisible by 2. 2 times anything is divisible by 2, right? So 2 divides 2 plus some integer. Thus, 2 divides k plus 1 squared plus k plus 1. And we are done. So that's it. Now, with division proofs, generally, you're going to want to resist the urge, like I said here, of combining like terms. You're going to want to look for your induction hypothesis in that sum, collect those terms, group what's left, and then make an argument and by using the induction hypothesis. All right, so that completes 31. I want to leave this note here. If you're watching this lecture, or this not quite lecture, but watching this explanation, if you watch the video for question 34, I'm going to refer to this proof from that question. So when we look at that question, I'm going to use this proof as part of the proof. So just keep that in mind if you go on and look at that video. If not, it doesn't matter. All right, QED, we are done. Thanks for watching. Please like and subscribe, maybe comment, do all those wonderful things that help YouTube video people. Thank you. Have a great night.